There are two variables. It might be time versus temperature. Let's take an interesting example. Sometimes it can also be the number of hours of studies, number of minutes of study versus the results of examination, versus the marks secured in the examination. Is it correlated? Yes or no? First question. That is where we talk about something called as R square. We'll also find out what is called as a correlation coefficient, whether it is strongly correlated, whether it is weakly correlated, or there are no correlation. Is instead of saying our subjectively, we collect data and derive objectively. In fact, it can also happen that till a particular number of hours, maybe it has got an impact on marks. And if you pressurize it more and more, the marks might decrease. How many of you agree with me? So let us take, for example, two things. Let me just plot on x-axis only, on the data on the y-axis. In this example, we are looking at some RNA transcript, gene X, in 5 different cells on x-axis. So generally, this gene X and Y are combined very significantly, okay? Your mother's genes, your father's genes, right? DNA, stuff like that. They are combined, you know, and they do sort of experimentation with it, okay? So there is a gene Y in the same 5 different cells on the y-axis, cell related, right? Okay, now, if the gene doesn't make much difference to you, imagine that we went into 5 different grocery stores and put the number of green apples on the x-axis and red apples on the y-axis. You can remember in whatever, there can be 2 variables, and we wanted to see the intersection of that. If this grows, whether this is also increasing or decreasing, or it doesn't matter. So each pair of measurement were taken from a single cell in case of gene or grocery stores, and can be represented by a blue dot. See, for example, here to here, there is a blue dot. For this to here, there is a blue dot. Just draw a horizontal line and a vertical line of these variables and connect it. So we can see that in general, relatively low values for gene X are paired with relatively low values for gene Y, which means that if gene X value is low, gene Y value is also low. And if gene X value is high, the gene Y value is also high. Like we saw in the first example where the time is high, temperature was also high till a particular point, okay? Another example that you can imagine is, suppose if you have a rubber band. How many of you remember the Young's modulus? If you don't remember Young's modulus, don't get scared, okay? Stress versus strain, right? Or if you pull a spring, the stress that you give and the length of it, the more strength that you give, the more length it will become. So that is the same thing. If you give less force, it will elongate a bit. If you give more, it will elongate a little more. If you give further more, it will elongate further more. If you give too much, again, it will not go back. Okay, that's called Young's modulus. Okay, stress versus strain. But I just want to tell you that here also in gene, if X values are red and Y values are low, X value is high, the Y value is high. So we can use a straight line with a positive slope to represent the strength. If you see, it's almost like X increases, Y increases, you can use a straight line with a positive slope or an angle, you can call, to represent this trend. And so, if someone told that they collected a new measurement as 20, we can say with a little confidence it will be somewhere here only. It can definitely not be 10. If it is 20, probably around 27. Okay. Or if somebody gave a value for gene Y, approximately you can say that X should be this. Or if you want to remember, in your city, for example, if somebody told the time is 10 o'clock, approximately you can guess the temperature. Yes or no? Or if somebody told you a temperature, you could approximately guess the time. So this is the same parallel example. Okay. So we could use this trend to predict a range of values for X. Or in other words, what I'm meaning is, though we know that at 6 o'clock it will be this temperature, at 11 o'clock it will be a higher temperature, but you cannot say exactly it will be that temperature. You can predict in the range of a temperature. Similarly, if temperature was told to you, you can predict the range of the time that it would be now. In those days, people used to see the position of the sun and tell you the time. So in both the cases, we made guesses based on the trend we observed in the data. Suppose, imagine a hypothetical case where the data was closer to the trend line. Then given the X value, we might guess the value of Y falls in the smaller range. In this case, the closer the data to the line, the more gene X can tell us about gene Y. Alternatively, we could say that the relationship between gene X and gene Y is very strong. There is a strong relationship. Suppose if the data were farther from the 10 range, then we might guess that the value of gene Y falls on a larger range, because one is here, one is here. So we may not guess it in a smaller range. That's what I wanted to communicate. So it can be anywhere of this. In this case, we could say the values of gene X tells us less about values of weak relationship. So it is a weak relationship. Alternatively, we could say that the relationship between gene X and gene Y is relatively weak. All we are saying is that we observed that low values of gene X tend to be paired with low values of gene Y. High values of gene X tend to be paired with relatively high values of gene Y. And that this observation suggests trend that we use to make predictions and inferences. This is also called as educated guesses. We are not ruling out the possibility that something else causes the trend that we observe. Okay. So far, we looked at a relatively weak relationship. So this is called weaker relationship, and this is stronger relationship. So this is to this extent that we have to understand. Okay. So we can quantify the strength of relationship with correlation. The life of the belt versus quality of the material, or in steel, they put different values of carbon and find out the strength of the steel, etc., etc. Okay. In other words, these data with a relatively weak relationship have a small correlation value. These data with a moderate relationship value have a moderate correlation value. And these data with strong relationship have a large correlation value. And I want to summarize this with this. The maximum value for correlation is 1. Correlation is 1 when a straight line with a positive slope. We can go through the center of every data point. So if correlation is 1, this is what we mean exactly. So put, instead of Gen X, Gen Y, you put anything that you want and try to relate it.